Research a concept as the enthalpy of solution. It is the enthalpy change that occurs when 1 mole of a substance dissolves in a solvent to form an infinitely dilute solution. But today we're going to learn the enthalpy of solution in relation to lattice energy and hydration energy. Enthalpy of solution when you're having lattice energy is calculated by enthalpy of solution is equals to negative of the lattice energy plus hydration energy. Let us learn what is lattice energy and hydration energy quickly before we go on. So what is lattice energy? Lattice energy is energy released when 1 mole of an ionic compound is formed from its constituent ions in a gaseous state. An example, we have an ionic compound like calcium chloride. It has been formed when calcium ions combine with 2 chloride ions. It will form calcium chloride. Another example is magnesium chloride. It is formed when magnesium ions combine with 2 chloride ions, and when they do so, this is bond formation. Bond formation is an exothermic process. There is some heat that is released or some energy that is released. That is what is called lattice energy. Energy released when an ionic compound is formed from its constituent gaseous ions or from its ions in gaseous state. That is it. Now, what about hydration energy? It is the energy released when 1 mole of gaseous ions interact with water molecules to form a solution of hydrated ions. Other books will say it is the the energy released when 1 mole of gaseous ions interact with water molecules and they become hydrated. For example, we have 1 mole of gaseous magnesium ions. When they interact with water molecules, they'll form 1 mole of aqueous magnesium ions. So that energy released in this process is what is called hydration energy. Hydration energy. Now, that is just simple. The same will occur when 1 mole of chloride ions interact with water molecules. Because they interact with water molecules and water is a polar compound, there will be bonds that will be formed. Bond formation is an exothermic process, meaning heat is being lost from the system. So that is why the enthalpy here is minus. What if we are dealing with the magnesium chloride? If there are 2 moles of the chloride ions in the gaseous state and they interact with the water, it means there will be 2 moles of the aqueous ions, meaning that the heat released will be twice. So that is why we're going to multiply here twice. Stay with me because I want us to use this magnesium chloride to learn about, or I want us to calculate the enthalpy of solution of magnesium chloride. From the beginning here, we have seen that the lattice energy for the formation of magnesium chloride, or the heat released when 1 mole of magnesium chloride is formed, is minus 3933 kilojoules per mole. I want you to know this. The same amount of energy released when 1 mole of magnesium chloride is formed will be equal to the same amount of energy released when 1 mole of magnesium chloride will be dissolved in water. This is what I mean. If I dissolved magnesium chloride in water, what will happen? So the question here is, what happens when an ionic compound is dissolved in a solvent? An example is water. Magnesium will separate into its constituent. Magnesium chloride will separate into its constituent gaseous ions, magnesium ions and chloride ions. This is bond breaking. Now, what do you know about bond breaking? Bond breaking is an endothermic process. Heat will be absorbed into the system. Number 2, I want you to know this, or even before we go to number 2, the same amount of energy that was lost during the bond formation is the same amount of energy that will be absorbed. So this energy, which is here, will simply be the negative of the lattice. So here it is negative 3,933 kilojoules, but here, because heat is being absorbed into the system, it will be positive 3,933 kilojoules per mole. Let us go next. The second thing that is going to happen when you have dissolved it, after it has formed or separated into its gaseous ions, these gaseous ions are going to interact with water molecules and they'll become hydrated. we have called that one hydration energy. So magnesium ions, when they are hydrated, because they are forming bonds with water, bond formation is an exothermic process. The energy released will be negative 1891 kilojoules. 1 mole of chloride ions in the gaseous state will interact and form the aqueous, or when they become hydrated, the energy released will be negative 384. What about when they are 2? So when they are 2, it will be twice. So how do I calculate the enthalpy of solution? It will be the negative of the lattice energy. I'll come here. What was the lattice energy? Negative 3,933. So it will be the negative the lattice energy plus the hydration energy. We calculate the hydration energy. We had 1 magnesium. When it was hydrated, it is negative 1891. This is negative 1891. There were 2 moles of chloride ions which were hydrated, so it was 2 times negative 384, like that one. When you add, the total of the hydration energy was coming to negative 2659. And when the negative lattice, when this multiply, it will be positive 3933. So the total sum was coming to positive 1274 kilojoule per mole. That is what is called the enthalpy of solution of magnesium chloride. It is simply gotten by the negative of the lattice plus hydration energy. It is simple. It is not difficult. It just comes from the basic understanding that when magnesium is dissolved in water, the first thing that happens, it will separate into its gaseous ions. Next, these gaseous ions, and remember this one, when it separates, it's bond breaking. So the reaction is what? Endothermic. Heat is being absorbed into the system. It is the opposite of the lattice. That is why it is called the negative of the lattice plus hydration energy. These ions are in gaseous state. When they interact with water molecules, they form bonds. And as they form bonds, heat is being released because bond formation is an exothermic process. So that is why here we're just going to add them the way they are. Negative 1891 plus that one. Yeah, your answer was coming to positive 1274 kilojoules per mole. Now, in the event that you are told to represent the information or the enthalpy of solution of magnesium chloride in an energy level diagram, what do? You just draw a diagram. Energy, reaction path. You begin when magnesium chloride was dissolved in water. Here, by the way, it's supposed to be in its solid state. When it was dissolved in water, it separates into its gaseous ions, magnesium and chloride ions. We have said this bond is bond breaking, separation. So it is the opposite of the lattice. It is the negative of the lattice, so it will be positive 3933 kilojoules per mole. Then these gaseous ions interact with water. They form bonds. Bond formation is what? It's an exothermic process. And in the process, they become hydrated. So magnesium aqueous. And then you have the chloride aqueous, like that one. Yeah, and this one will be called the what? The hydration energy. The sum total which you got is that one right here. Then lastly, enthalpy of solution. Enthalpy of solution. That is how you calculate the enthalpy of solution. It is simply the difference between this one and this one. It is the enthalpy of solution. Yeah, it was coming to positive 1274 kilojoules per mole. And that is how you do it. Have a lovely time. If you have a question, write in my email, chemquest@gmail.com.